May adlaw sa tanan. So today, I will going to discuss or to share some learnings I have, which is the chapter 2, all about early management system. So to introduce this chapter, the four types of memory allocation schemes are single user systems, fixed partitions, dynamic partitions, or best fit versus first fit allocation, deallocation. Lastly, relocatable dynamic partitions. There are four types of operating systems. Number one, real time operating system. Second, single user or single tasking operating system. Third, single user or multitasking operating system. Lastly, multi-user or multitasking operating system. Real-time operating system is designed to run real-time applications. It can be both single and multitasking. Examples may include Abasai, AMX, RTOS, or etc. Advantages of real-time operating system: it works very fast. It is time saving as it need not be loaded from memory. Since it is very small, it occupies less space in memory. Single user or single tasking OS. An operating system that allows a single user to perform only one task at a time is called a single user, single tasking operating system. Functions like printing a document, downloading images, or etc., and can be performed only one at a time. Examples of this: MS or the OS, PAM OS, and etc. Advantages of single user or single tasking OS: this operating system occupies less space in memory. Disadvantages: it can perform only a single task at a time. Single user or multitasking OS. An operating system that allows a single user to perform more than one task at a time is called single user multitasking operating system. Example of this: Microsoft Windows and Macintosh OS. Advantages: it is time saving as it performs multiple tasks at a time, yielding high productivity. Disadvantages: this operating system is highly complex and occupies more space. Multi-user or multitasking OS. It is an operating system that permits several users to utilize the programs that are concurrently running on a single network server. The single network server is termed as terminal server. Terminal client is a software that supports user sessions. Examples include Unix, MVS, and etc. Advantages: it is highly productivity as it performs multiple tasks at a time. Then it is time saving as we don't have to make changes in many desktops. Instead, can make changes only to the server. Disadvantages: if the connection to the server is broken, user cannot perform any task on the client as it is connected to the server. Fixed partitions. Commercially available in 1950s and 1960s. Main memory is partitioned. At a system startup, one contiguous partition per job permits multiple programming. Partition sizes remain static, must shut down computer system to reconfigure, and it requires protection of the job's memory space, matching job size with partition size. Disadvantages of fixed partitions: requires contiguous loading of entire program, job allocation method, Then, first available partition with required size to work well. All jobs must be same size and memory size known ahead of time. Arbitrary partition size leads to undesired results. Partition too small, large jobs have longer turnaround time. Partition too large, memory waste and internal fragmentation. Then, dynamic partitions. Main memory is partitions, jobs given memory requested when loaded, one contiguous partitioner per job. Job allocation method. First come, first serve allocation methods. Memory waste, comparatively small. Then disadvantage, full memory utilization only during loading of first jobs. Then subsequent allocation, memory waste, external fragmentation, fragments between blocks. Best fit versus first fit allocation. Some methods for free space allocation. First fit memory of allocation. First partition fitting the requirements leads to fast allocation of memory space. Best fit memory allocation. Smallest partition fitting the requirements results in least wasted space. Internal fragmentation reduced but not eliminated. Fixed and dynamic memory allocation schemes use both methods. First, fit memory allocation. Advantage, faster in making allocation. Disadvantage, leads to memory waste. Then best fit memory allocation. Advantage, makes the best use of memory space. Disadvantage, slower in making allocation. Okay, so I have here a figure, and as we can see it, the best fit versus first fit allocation. So using a first fit scheme, job 1 claims the first available space, then job 2 then claims the first partition large enough to accommodate. But by doing so, it takes the last block large enough to accommodate job 3. Therefore, job 3 indicated by the asterisk must wait until a large block becomes available, even though there is 75K of unused memory space. Internal fragmentation. Notice that the memory list is ordered according to the memory location. Algorithm for first fit assumes memory manager keeps two lists, one for free memory, one for basic memory blocks. Loop compares the size of each job to the size of each memory block until a block is found that is large enough to fit in the job. Job start into the block of memory. Memory manager moves out of the loop, fetches next job from the intrigue key. The allocation. Freeing allocated memory space. For fixed partition system, straightforward processes. Memory manager resets the status of job's memory block to free upon job completion. Any code may be used. Example code, binary values with 0 indicating free and 1 indicating busy. Case 1. Join two free blocks. Blocks are adjacent. This changes to reflect starting address of the new free block. Example 77,600. The address of the first instruction of the job that just released this block. Memory block size changes to suit its new size for the new free space. Combined total of the two free partitions. Example 200 plus 5. Case 2. Deallocating an isolated block. Deallocated memory space, then isolated from other free areas. System determines a released memory block status, not adjacent to any free blocks of memory, between two other basic areas. Then system searches table for a null entry and occurs when memory block between two other basic memory blocks is returned to the free list. relocatable dynamic partitions. Memory Manager relocates programs, gathers together all empty blocks, compact the empty blocks, then make one block of memory large enough to accommodate some or all of the jobs waiting to get in. Then Unpaction, reclaiming fragmented sections of memory space. Every program in memory must be relocated. Programs become contiguous. Operating system must distinguish between addresses and the data values. Every address adjusted to account for the program's new location in memory. Data values left down. Okay, I have here a figure. Relocatable dynamic partitions. So an assembly language program that performs a simple incremental operation. This is what the programmer submits to the assembler. The commands are shown on the left and the comments explaining each command are shown on the right after the semicolons. Another figure. Let's just observe and see it. As the original assembly language program after it has been processed by the assembler. To run the program, the assembler translated into machine readable code shown on the left, with all addresses marked by a special symbol, shown here as an apostrophe to distinguish addresses from data values. I am Darnpol A. Ascension from BS IT2B and happy learning!